Hi guys, welcome to the channel. So we were discussing about the selection rules governing the possibility of excitation. So there will be two rules which will govern the possibility of excitation from bonding molecular orbital or non-bonding molecular orbital to the anti-bonding molecular orbital. So the first selection rule will be that there will be net retention in the spin after transition. That means, suppose if we are having some sort of transition from bonding or non-bonding molecular orbital to the anti-bonding molecular orbital, then change in spin will be zero. That is, there will be net retention in the spin. So if before transition the spin is suppose plus half, after transition the spin should be plus half. Or there could be another case that before transition if spin is minus half, then after the transition the spin should be minus half. This is the first criteria, and this is the first rule governing the possibility of excitation. Now moving on to the second rule, which is by symmetry. So for knowing this rule, we have to know about what is gerade and what is ungerade. After that we will go for which transitions will be allowed and which will be not allowed. So first we will go for what are gerade and ungerade, and then we will look for symmetrically allowed or forbidden transitions, right? So if we are talking about symmetry, so it could be gerade or it could be ungerade. People might call it gerard or ungerard or gerade or ungerade. So we represent it like G and U. G for gerade and U for ungerade. So in case of gerade, we will be having the center of symmetry, COS, center of symmetry designated by small I. So center of symmetry will be present in case of gerade, and in case of ungerade, that is center of symmetry represented by small I, this will be absent. Now let's understand this with the help of example. Suppose we will take one orbital. Suppose we are taking s orbital. So we know how s orbital looks like. It is spherical in shape. So now we have this s orbital. We have these positives over here all over the sphere. So this is some type of a s orbital. If we want to know whether it is gerade or ungerade, what we have to do is take the center. This is the center, and from center try to move in any direction. Suppose I'm moving in this direction. In this direction I'm going to find positive sign, and just move to the opposite direction of it. In the opposite direction of it, again I'll find the positive sign. I'm moving in some other direction. If I move in this direction, then again I'm going to find the positive sign. In this direction also I'm going to find the positive sign. Similarly, in any of the direction, if I'm moving and then I'm moving to its opposite direction, I'm going to find the same sign. So if I'm going to find the same sign, that means center of symmetry is present. Right, center of symmetry is present. So if center of symmetry is present, then this is gerade. Now moving on to the second example. Now take the example of p orbital. P orbital is somewhat like this: positive lobe over here and negative lobe over here. Now again we will try to move in different directions. So now take the center. This is the center. if I move in this direction, I'm going to find positive sign, and in this direction I will try to find, and in this direction I will find the negative sign, right? If I'm moving in this direction, I'm getting the positive sign, and in the opposite direction of it, I'm finding the negative sign. So in this case, I will be absent. If I is absent, then that means it is unzeroed. Now these are the two orbitals. Again, if I want to go for some other orbital, suppose I'm taking the d orbital. Now talking about d orbital, d orbital is like this. These are the two positive lobes and these are the two negative lobes. Now I want to find out whether it is geroid or ungeroid. So what will I do? This is the center. From here I'll try to move in this direction, negative sign, and in the opposite direction again, negative sign. If I'm moving in this direction, positive sign. In this direction, again positive sign. So I'm finding the same signs in the opposite directions. In this case, I is present, molecule is geroid, right? Now if you don't want to mess things up like this, you can learn one more thing, that is, if you are having s, p, d, f, these orbitals, then symmetry goes like this. For s you have geroid, p you have ungeroid, for d you have geroid, for f you have ungeroid. Alternatively, you get the symmetries geroid, ungeroid, geroid, ungeroid for s, p, d and f orbitals. Now moving to hybridized orbitals. These were not hybridized orbitals. Now we will move on to the symmetry of hybridized orbitals. Now talking about the hybridized orbitals. So first I will take pi bonding molecular orbital. So it looks like this. Positive, positive and negative, negative. Now this is the pi bonding molecular orbital. Now I want to find out the symmetry. Again, same thing. Take the center. Now I'll move in this direction, I'll find positive sign. I'll move in this direction, I'll find negative sign. If I move in this direction, I get positive, and in the opposite direction, I'll get the negative sign. So in the opposite directions, we are getting the different signs. So in this case, center of symmetry is absent. So the molecule is ungeroid. This is about pi molecular orbital. Pi bonding molecular orbital. Now moving on to pi star. Pi star molecular orbital, or you can say pi anti-bonding molecular orbital. So in that case, plus and plus here, minus and minus here. These will be the orientation of lobes. Now again, I'll take the center. From here I'll move to this direction, negative sign, and in the opposite direction again the negative sign. In this direction positive sign, and in the opposite direction the positive sign again. So we are finding the similar signs in the opposite directions. In that case, we have center of symmetry present. So the molecule is geroid. Right? Now we will talk about the second rule out of the two rules which we were discussing. These were the two rules for selection, right, which were governing the possibility of excitation. So these were the two rules. So first rule we have discussed, this was the second rule. Now we know what is geroid and what is ungeroid. So transition will be allowed if the transition is taking place and before and after transition, this symmetry is same. Like transition is taking place is not same, sorry. If transition is taking place from gyrate to ungyrate, then that is allowed, right? And from ungyrate to gyrate, that will also be allowed. But if before and after transition symmetry is same, that is from gyrate to gyrate transition is happening and from ungyrate to ungyrate transition is happening, then in that case transitions will be forbidden, right? So these are the two rules. So if we look at the different orbitals, so if we take the case of sigma to sigma star transition, now look, in this case sigma is gyrate, right? We have discussed this. And sigma star is ungyrate. From gyrate to ungyrate, gyrate to ungyrate transition is allowed. So this is allowed transition symmetrically. This is symmetrically allowed transition. Again, I'll take another case. Suppose we have some pi to pi star transition. Okay, in this case again we know that pi is ungyrate, this we have discussed, and pi star is gyrate. From ungyrate to gyrate transition is allowed, right? So this is also symmetrically allowed transition. Okay, now if I talk about other case, suppose I have transition from pi to sigma star. In this case pi is ungyrate, sigma star, this is also ungyrate. From ungyrate to ungyrate transition is not allowed. So this is symmetrically forbidden. Symmetrically forbidden. Now one more case, if we have transition from sigma to pi star. In this case sigma is gyrate, pi star is gyrate. So from gyrate to gyrate it is not allowed, it is forbidden. So again it is a forbidden transition, symmetrically forbidden transition. So these are the two selection rules which govern the possibility of excitation. So first is there should be net retention in the spin before and after transition, and secondly the symmetry should change from gyrate to ungyrate or from ungyrate to gyrate, right? So these are the two rules. Now this is it about the topic. Now after this we will move on to the next topic, maybe that is going to be the formation of absorption bands.